F prime g plus f g prime. So x becomes 1, g stays the same, f stays the same, and g prime. The rule for e to the u is e to the u times u prime. So e to the u is e to the sine 2y. And now we got to worry about building the derivative for the entire exponent. So sine of 2y becomes cosine of 2y times 2. We're also asking for y's derivative, so dy dx. Okay. Any questions getting from g to g prime? All right, 4x becomes 4, natural log of y becomes 1 over y, dy dx. We expected 2 dy dx to show up, and there they are. All right, so now we have 4 separate terms. We're just going to arrange them so that we can get the dy dx terms on the same side. The non-dy dx terms pushed to the other side. Factor dy dx and solve for your derivative. Any questions with number 2? All right, number 3, find the equation of the tangent line to our function. So we have an ordered pair. We need to find the slope. To find the slope, we got to get to the derivative. To get the derivative, we have to rely on what? Product rule, yeah. So the x is separate from the arc cosine of x squared. So they're 2 separate terms. And the arc cosine is similar to the arc sine, right? So the negative version of it. So there's your reminder. Maybe at the end of class, we can go through another practice with working on our derivative rules. But arc cosine is similar to arc sine. We know that all of our arc trig has a u prime above and a combination of 1 and u squared in the denominator. In this case, arc cosine is the square root of 1 minus u squared. Okay, try that. Find your derivative. Okay, f prime g plus f g prime, x becomes 1, g stays the same, f stays the same. Arc cosine of x squared becomes negative 2x, square root of 1 minus x squared squared, so x to the 4th. Once you have your derivative, we're ready to move into using that to find the slope. Replace all your x values with 0. The right side all cleans up, reaches 0. Our cosine of 0 is asking what theta value allows cosine to be 0? When theta is what? Cosine of what is equal to 0? Pi over 2, yeah. And 3 pi over 2, but 3 pi over 2 is outside the domain, so we don't have to include that. So we have our slope, we have our order pair, and slope form. Because at the beginning of the problem, it says the given domain is from 0 to pi. So we have to, yeah, we have to keep the x value there. Number 4, related rates problem. But let me draw the diagram for you. And also the diagram will be drawn for you on the test. You don't have to draw the diagram yourself. But does anybody still need to look at number 3? Sorry, down here. All right, a camera on the ground 200 meters away from the hot air balloon records the balloon rising in the sky at a constant rate of 10 meters per second. How fast is the camera's angle of elevation changing when the balloon is 150 meters in the air? So first, we're going to just start off building our trig equation. We're going to involve the horizontal and vertical. So which trig equation would be the best fit? Tangent, yeah. We don't have to put a variable here because this is a constant. As the balloon continues to rise, we expect the theta to be changing. We expect y to be changing. We also expect the hypotenuse to be changing. But this distance from the camera to the launching point of the balloon is not going to change. So if something is unchanging all the way through, we don't have to have a variable. We can just have a constant represent that side. So tangent theta equals y over 200. And also, we do have information about how high the balloon is at 150 meters up in the air, but this is just a moment in time, right? Any moment before, any moment after, that balloon is continuing to rise. We don't want to force that to be 150 if it's not going to be the entire time through. So we're creating a trig equation. Anything that is changing, we have to hold on to that variable until after the derivative. After the derivative, then we can plug in that specific moment in time. All right, if you want to go through quotient rule, you can. F prime g minus f g prime all over g squared, but anytime there's a constant, I like to avoid quotient rule. So how can I rewrite it to make it a little bit easier to see just the need for power rule? Y over 200, the same thing as what? times y. Yeah, that just feels a little bit cleaner. You don't have to do that, but it just feels a little bit easier to see the power rule that we can do there. Okay, related derivative. Remember related rates. Every variable is going to get impacted by time. Tangent theta becomes what? What's tangent derivative? Okay, secant squared theta times secant squared theta. We're almost done with the derivative. We have to there's a time component that has to be involved here. So times what? D theta of dt. Yeah, that's the thing with related rates. Every variable is going to have a time derivative, component derivative that's going to be attached. Okay. All right, what's the derivative of 1 over 200 times y? Yep, coefficient is going to stay. Y becomes 1 and then dy dt. Yep. You don't have to put that 1 there, but okay, so every variable that you see is going to produce their own derivative time component. Okay, how fast the camera's angle of elevation changing? We're looking for d theta dt. That's our unknown. The balloon is rising in the sky at a constant rate of 10 meters per second. What information is that? dt, positive or negative? Okay. What's happening to y as time passes? Increasing, yeah, so positive 10. When the balloon is 150 meters up in the air. So that's, now we can involve that 150 later on when we want to build that second triangle. Okay, so dy dt, we have a replacement for that. D theta dt, we know we're looking for that variable, so that's showing up. So what else do we need to replace? Okay, secant of theta, not theta, secant of theta. So we have to find a replacement for secant of theta. We could fill in numbers on this triangle, but it just feels a little messy. I just want to draw a second triangle just with numbers to help me get the numbers the ratio that I'm looking for. Okay, so I know that this is 200. What is y at this moment in time? Pythagorean theorem can get you that hypotenuse. A squared plus b squared equals c squared. 250, yeah, use your calculator. So our goal is to figure out that ratio, right? What's secant of theta? Right? Which can use what numbers then? Good. Yeah, cosine is adjacent over hypotenuse. Therefore, secant is 250 hypotenuse over adjacent. Yeah. All right, everything we need is now ready to plug in. Now we're just going to plug in 5/4 in for secant, make sure we square that, replace dy dt with 10, and then try to find a way to get d theta dt by itself. I get 25 over 16. Dividing by 25 over 16 is the same thing as multiplying by 16 over 25. Yeah. Use your calculator, get it down to a number. What's our unit of measure? Get radians per second. All right, let's do another full curve sketching problem. Okay, so start the process here. Find f prime. Set f prime equal to 0. Find your critical points. Start populating your sign line. So if you guys go ahead and start that, and I'll work the problem through as well. Okay, does anybody still need the related rates problem? Okay, where's sine equal to -1/2? Yeah, in the pi over 6 family, yep. Which quadrant? Third and fourth. Okay, so I'm going to start off with something that I recognize first, 7 pi over 6, 11 pi over 6, but we see that we have negatives in our interval. So let's subtract 2 pi from each of these original just to get some coterminal angles. So um, seven minus 12, I get negative 5 pi over 6. 11 minus 12, negative pi over 6. Hey, we're looking for something that is going to fall in that interval from -1 pi to positive pi. And both of these we can fit. And so this is more like the problem that you're going to see on the test. You can, as soon as you find one of the slope behavior, your other parts of the graph will alternate between them. So I'm going to test 0 here. Into the derivative, sine of 0 is 0. 1/2 plus 0 is positive. So we're expecting a relative max at -5 pi over 6, relative min at -5 over 6. Let's find the order pairs later. Let's just indicate the x values. And let's also practice writing out our because statements. All right, let's do our second derivative function, f double prime. Pick up where we left off. F prime was 1/2 plus sine of x. 1/2 becomes sine x becomes positive, right? Positive plus sine. That equal to 0. Okay, where is cosine equal to 0? Subtract 2 pi from each of them to see if we can have anything that's going to land. Okay, negative 3 pi over 2 and negative pi over 2. Negative pi over 2 is something that we can use. Oops, sorry, negative pi to pi. So a convenient value is 0. 0 into f double prime, cosine of 0, positive. Then we know that others are going to alternate. Okay, how many points of inflections do we have? 2, because there's a change in signs. Let me just go ahead and find order pairs. These are a little bit easier to do, so let's get that out of the way. Back into the original function. Yes. Uh, well, cosine of 0 is equal to 1, so we can just say that's positive, right? Positive value. Okay, yeah, you can go. Sorry. Yeah. Okay, are we okay here? So let me find the order pair just to get that out of the way. So negative pi over 2, and for x into original function, I get negative pi over 4. Cosine of negative pi over 2 is the same thing as cosine of pi over 2. Sorry, as 3 pi over 2, which is going to be 0. So 1/2 times negative pi over 2 minus 0, which is going to be negative pi over 4. So that's one order pair. The other order pair, pi over 2 into the original function, we get pi over 4 minus cosine of pi over 2. The pi over 2 is still 0, so just pi over 4. What's our reasoning for point inflection? Because double prime changes sign, yeah. All right, concave up, concave down. We can just read that from our concavity sign line. Okay, absolute max, absolute extrema, absolute max, absolute min. What is that applying here? EBT. And EBT means we want to find critical points and endpoints. We only need to look at which sign line for our candidates. Which sign line do we look at for EBT? Both or one? Just first derivative, yeah. F double prime is concavity. Points of inflection is not going to be a peak or valley, so you only need to consider points from your F prime sign line. Right? We are going to consider both our critical points because these do end up being max and min. So we're going to find the location at each of these x values into the original function and compare their y values. We can after you get the exact value, you can use our calculator to get a decimal representation, so it'll be easier to compare. That's from the F prime sign line. That's all we need to consider. Okay, let me write the function so it'll be easy to access. Okay, so let's test negative pi first, or find the order pair there. Cosine negative pi, same thing as cosine of pi, which is -1. Two negatives makes positive. Okay. Critical point. Put that in for x. If you don't recognize -5 pi over 6, you can always add 2 pi to get something more familiar. -5 pi over 6, same thing as 7 pi over 6, right? If we add 12 pi over 6. So cosine 7 pi over 6 is going to be in that pi over 6 family, third quadrant, √3/2, but it's going to be negative. Two negatives makes positive. Okay, next critical point, back into the original function to get the order pair. Cosine -pi over 6, that's the same thing as if I add 2 pi, I get 11 pi over 6. So fourth quadrant, still in that pi over 6 family. Positive √3/2, but then there's negative here, so minus √3/2. And finally, my endpoint, f of pi, into the original function. Pi over 2 minus a -1. Okay, we have all the order pairs. Well, let's see. Now we can use our calculator to kind of have some idea as to where these values are in terms of approximation. So I'm just going to plug them into the calculator here, just for comparison purposes, so I can see what's going to be the highest, what's going to be the lowest, and also for graphing purposes too, easier to do some ballpark estimations on our graph if we kind of have an idea where these points are. Oops, sorry. I bet -5 pi over 6 is closer to 0 there. So if I'm comparing between these candidates, my highest y value is 2.57, so there's my max. My lowest y value is negative 1.128, so that's my minimum. So, and what you want to represent with my exact value, so just the y values for your absolute max, absolute min. Yeah, what's the I want you to give me the exact value. Yeah, I think that the decimal is good for comparison purposes, but once you know which one is higher, which one is lower, then give me the exact value. But these decimal values will also be helpful as we want to place them onto our graph so that we can connect the dots and sketch our graph. So let's place all the important points that we care about, which are basically all the points from your sine line. You can scale them however way you want to. Um, looks like my highest y value is going to be closest to 3, so, and then my lowest y value is going to be barely past -1. Okay, so negative pi is around negative 0.57. Negative 5 pi over 6 is around negative 0.4. It's a little bit higher, enough to be a relative max. Negative pi over 2 is at negative pi over 4. So that's around negative 0.75, so a little bit lower. Negative pi over 6, negative 1.128. There's my relative minimum. Pi over 2, if I go to my points of inflection, that's going to be at pi over 4, which is around 0.75. And then at pi, 2.57. Right? If I follow my slope sine line, I want my graph to increase, decrease, and then increase again. If I follow my concavity sine line, up until pi over 2, it'll be concave down. Sorry, up until negative pi over 2 is concave down. Between negative pi over 2 and pi over 2, concave up. And then to the right of pi over 2, concave down. Oh, before we continue on, do you guys have some space here? Let's practice our derivative rules. So let's just worry about, well, let's do the arc trig ones. Right, so remember that all your numerator is just what? Just u prime. The easiest one is the arctangent. It's got no absolute value. It's got no square root. It has no negative sign. The denominator is just going to be what? 1 plus u squared. Okay. Every one of your rules has a 1 and u squared in the denominator. We should have to figure out how they're combined. Okay, arcsecant's got the most complicated looking one. It's got the absolute value of u. It's got the square roots. And how is u squared and 1 going to be looking like inside the square roots? U squared, what? Minus 1. And what helps me remember that is u squared coming first instead of the 1 is I know the u's are next to each other, so that helps me organize what's inside. And having this order is helpful because I know that my arc sine is going to be a little bit different order. So what's inside the square root for arc sine? Yeah, 1 minus u squared. Yeah. Okay. And then your arc cosine, arc cotangent, arc cosecant, you can just copy the ones to the left of it and just put a negative in front of all those derivatives. So this will be negative u prime over root minus 1 u squared. This will be negative u prime over 1 plus u squared. This will be negative u prime over epsilon u squared minus 1. All right, next page. On Monday, I'm just checking pages 5 and 6. So we're just getting ahead with our work from Monday. Right, look at number 1. What do we have to involve here for derivative product rule? Yeah. And then we have two rules, e to the u times u prime, and then inverse cosecant, which is similar to your arcsecant, just a negative version of it. All right, try that. Sorry, say again? Yes, simplified is fine. Fine, yeah. Or you can, yeah, or you can merge these together under the same fraction. Yeah, I didn't go any further there. Any questions with one? All right, what do you see for number two? We're just have to find the derivative here.
Oh, yeah, implicit, product rule.
Implicit and product rule, okay. How many dy dx's? Three, yeah. We have three, dy dx's. Yeah. Okay, just to remind you, a couple of rules that involved here. E to the u is e to the u times u prime. Secant is secant u tangent u times u prime. Natural log is u prime over u. Arctangent is u prime over 1 plus u squared.
Moves.
Take f prime g plus f g prime, y becomes dy dx, arctangent stays, y stays, and then arctangent of u is u prime over 1 plus u squared. We're asking for y's derivative, so we need to attach that dy dx. E to the u becomes e to the u times g prime, e to the 2y times e to the 2y times 2. Another y variable is involved, so another dy dx shows up. Minus 6x squared. Secant of u becomes secant u tangent u times u prime. Natural log of u is u prime over, sorry, u prime over u. So we have 6 terms that we're trying to keep track of. So we'll move the terms that have dy dx together on the same side. I did it on the left side. The non-dy dx terms, I moved it to group them together on the right side. Factor your dy dx out and then divide over. No need to simplify. Okay, just gonna check, worksheet 3 on Monday. And we'll continue working on worksheet 4. Monday.
You know, I think they should the last 20 minutes. I know I've been listening.
No, we just that I haven't been talking back.
I don't think that.
I would have loved to be able to listen to what I'm saying in the class instead of hearing the whole class.
Yeah, the only time it's something left.
Everyone's all.
So why don't you help me?
No, our car.
I don't think that.
You just got it.
Have a great weekend, guys. Oh, this one here.
Yeah, during like.
Oh, yeah, you're right. There's another negative because of arcs cosecants, so that comes positive. Yeah, you're right. You're right. Thank you. Appreciate it. Thank you.
Thank you, Mr.
Thank you.
Good luck.
Bye. Have a good weekend. Thank you. Want to take it now? Or?
Yeah.
Okay, yeah.
Put your foot back in the front. Yeah. Also the homework answer there, so that will.
Sure.
Yes.
Okay, great. Maybe, we can pick up that, that's the morning review for your quiz. I'll just.
Wasn't like actually allowed to write down the answers. So I didn't mind cooking meat.
And resolve that, oh my God.
There's no negativity for. Don't want to like the
You know what, Michael, you just show me things once they don't ever just want to pause their life.
Yes, you should.
Maybe it'll be fine.
You know, I know you can stop. It's a good thing.
There you go.
You're not wearing the right color. I think so. Random color. No, can I take a look? Okay. That is right.
Okay. Blue is left, let's know.
It's a white thing. Expect better from you. Yeah, I'm a
No, I feel like you're.
Okay, well, Be awake at 7 o'clock, yeah.
I really appreciate it. I'm starting to. No, I'm getting so much.
I have 13 here.
No, because I think like, that's exactly like.
That's a late bird.
Like, super like.
Definitely never did.
You just copy the traffic.
Okay, well, Matthew.
Oh, yeah.
Where did
Yeah, these are these there and these are.
I didn't already hear that. Unfair about it. Well, that was a bad question to ask, actually. You definitely not be like, I'm not exactly confident. Yeah. I feel like we're probably. Yeah. I don't even know.